An open box with a square base is to be made from a square piece of cardboard 36 inches on a side by cutting out a square from each corner and turning up the sides. And we're supposed to look at this figure, which I've drawn a little bigger here. It's 36 inches on each side, and then we're going to cut a square corner off of each corner here, and there will be X in length on each side of this square that's going to be cut out. Now the result, after you fold up the sides, is going to be a box, and I'll try to draw a reasonable three-dimensional figure here. That would somewhat resemble what the result is going to be. So the box will look something like this after we fold up the sides. But the whole point is that this edge right here would be 36, so this edge right here, minus this x minus this x. So this little piece right here is this side that's left. So that would be 36 minus two x's, this x and that x. And then since it's square, that means that this side over here is going to be the same. 36 minus 2x. And the height of this thing is going to be this right here. Each one of these, when we flip up these corners, we're going to bend it right here, and here, and here, and here. And we're going to flip these up, what's left here, after we cut these pieces out. And so this will represent that height right there. So that's going to be x, 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 x. So now the question is, what's the volume? Well, the volume is going to be length times width times height for a three-dimensional rectangular figure like this. So this volume expressed as a function of x will be the length, that's 36 minus 2x, times the width, that's also 36 minus 2x, times the height, which is x, which we could express as x times 36 minus 2x squared. The next question says, what is the volume if a 7-inch square is cut out? So that means then that x is 7. So if we find v of 7, this is going to give us 7 times 36 minus 2 times 7 squared. So we're going to have 7 times 36 minus 14. We're going to do what's in parentheses first. And the first thing to do in there is the multiplication. So 14. And 36 minus 14 is going to give us 22 squared, which is going to give us 3388. What is the volume if a 16-inch square is cut out? So now we're going to plug 16 in here for x. In here, rather. Here and here. So V of 16 is going to be 16 times 36 minus 2 times 16, or 32, just save ourselves a little bit of room here, squared. So we have 16 times 4 squared, or in other words 16 times 16, or 16 squared, which will give us 256. Now we're supposed to graph the function. And we have some graphs to choose from here. Let's go ahead and write down the function again. V of x equal to x times 36 minus 2x squared. Now here's what we know. If we set this thing equal to 0, we're going to get zeros at x equals 0 and at x equals 18. We also know that x equals 18 will be a touch-off point, since 36 minus 2x is squared in this function. We know that x equals 0 will be a pass-through point. So let's look at these graphs. This one has a 0 at 0 and a 0 at what appears to be 18. These are obviously units of 3, since we have 21 here at the 7th grid mark. But we've passed through this 18 value here. So we know that's not it. It's got to be a touch-off point. So we look at the next one. And we have a 0 here where we expected, right through the origin at 0, 0. And then we have a touch-off point at 18. And this one appears to be our graph. Let's just look at the others and see what they look like. Again, we have a intercept at 0, 0, but we again have a pass-through point at 18. So that's not going to be it. And on the D graph, again, we have a pass-through point at 18. So our selection is going to be B. The next question is, for what value of x is V largest? And since these marks here are 3's, then this x mark here appears to be 6. And the question is, for what value of x? And here then is our x-axis, and so we're looking for this value here on the x-axis. So our value then is going to be 6.